Welcome back, Algebra 2 Trig.
Mr. Yang sucks.
Okay, so today we're going to start with 5.3, trig functions of any angles. And the essential question is, how do I evaluate trig functions of any angle? First thing that we need to copy down is the definition of trig functions of any angle. I believe you guys may have copied this already, but let's go ahead and copy it again into our notes, because this is going to be essential for calculating all of the different trig functions of different quadrants. Okay, so up until now we have only been doing trig values in quadrant 1. So in the examples today we're going to be in quadrant 2, 3, and 4, and that's going to change your values just a little bit. Alright, so moving on, let's go ahead and start example 1. So example 1, let's go ahead and write this in. Let -5, 12 be a point on the terminal side of theta. And then what you're going to find is find sine, cosine, and tangent of theta. Okay, so the first thing that we actually need to do for this type of problem is to sketch it out. So I'm going to draw a very rough sketch. Technically this is going to be a regular coordinate plane, and for -5, 12 we're going to move to the left 5 units and then up by 12 units. So just a rough estimate, it's going to be -5, 12, and we're starting from the origin. Okay. So theta is actually the angle starting from this initial, going all the way to the line or the line segment that contains the terminal point, -5, 12. So this is theta. Now in terms of actually finding our trig identities, the triangle that we're going to use to help us is actually the one that lines up with this one over here. Because if you may recall, with your unit circle, all of the triangles were lined up against the pi, 2 pi axis. Okay, so we have to have a triangle that lines up here, and this right here will be our r value. In other words, kind of think of it as the radius. So I know that this one is going to be 12, and I know that this is -5. So I already have these values, and I need to figure out r. So r is going to be calculated as the square root of -5 squared plus 12 squared. That's going to be square root of 25 plus 144. So the square root of 169 is 13. Okay, so our triangle is a -5, 12, 13 triangle. And basically all you're going to do now is find sine, cosine, and tangent. So sine of theta will be opposite over hypotenuse, so 12 over 13. Or, based on the definitions that you just copied down, these guys, y over r. So this is my y value, my x value. So y over r, 12 over 13. Okay. Cosine of theta will be x over r, and that's going to be -5 over 13. And then tangent of theta will be y over x, and that's 12 over -5. Okay? So that's example 1. We're going to go ahead and set up another set of notes real quick before we can start example 2. Now there's something that's going to help us kind of figure out what goes where based on given information. And the first thing I need to draw in for us is a coordinate plane that gives us this information. First off, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, sine, cosine, and tangent are all positive. in quadrant 2, only sine is positive. Cosine and tangent will have negative values. Okay, and that's actually seen right here. We have negative 5 over 13 and 12 over negative 5. And only sine was positive. Down here, only tangent will be positive. And down here, only cosine will be positive. Now there is a little trick to remember this. This one is all. This one is students. Take calculus. And you will all take calculus. So all students take calculus. And now how does that help me? Well, first off, all means that all of my trig identities will work or will be positive in quadrant 1. Students tells me that only sine will be positive, and then so on and so forth. Take calculus, tangent, and cosine. All right? That's going to be very useful in the next example because there will be times where, well, we're going to see. Okay? So moving on to example 2. So example 2, we're going to continue to evaluate more trig functions. And with this one, we're going to be given sine theta equals negative 4/5 and tangent theta is greater than 0. I need to find cosine theta and cotangent theta. Now here's the issue with this. If I had only been given sine theta equals negative 4/5, this is actually possible in both quadrants 3 and quadrant 4. Because in those two quadrants, that's where sine could be negative. However, with the additional rule, or given information that tangent theta is going to be greater than 0, I can narrow it down and figure out that the only place where sine is negative and tangent is positive is in the third quadrant. So I know that we are going to be in quadrant 3. So based on that knowledge, I can go ahead and do a quick sketch of my figure. So I'm going to have a certain measure theta, and this is going to be not to scale. So negative 4. And the reason it's negative 4 is because when we're talking about sine, we're talking about opposite over hypotenuse. So negative 4 would be our opposite value, and 5 would be our hypotenuse. Over in here, if you remember your certain special right triangles, you'll actually know that this is going to be 3. And because it's on the left side, it is a negative 3. Okay? So with all of that information, we can actually calculate cosine theta really quickly. Cosine theta is equal to x over r. You could also just look at your figure and actually find cosine theta. But our x value is negative 3, and our r value is 5. So cosine theta is negative 3 over 5. Cotangent theta, that's going to be x over y, because tangent theta is y over x. X over y will give me negative 3, negative 4, which is 3/4. Now what you should notice is that cotangent theta also ends up being positive in here. So basically, sine and cosecant are positive in the same area, and cosine and secant are in this positive in the same area, right? Because they're basically the same thing, just reciprocal, right? Moving on to the last example then, we have example 3. This one's just not too difficult. We are going to do a lot more evaluation though. So evaluate the sine and tangent functions at the angles 0, pi over 2, pi, and 3 pi over 2. This is where your unit circle is going to really come in handy, and I'm going to sketch it just as a reminder for us. So, quick sketch. Over here, 1, 0. is 0. 0, 1, pi over 2. Negative 1, 0 at pi. And then finally 0, negative 1 at 3 pi over 2. Okay, so that was in your unit circle, and we're just going to go ahead and use the definition of trig functions to quickly evaluate all of these. So sine theta is always equal to the y value over r. Now in these problems we don't have like a triangle to look at. However, r, again, just refers to the radius. So in all of these values here, r is going to be equal 1. So let's keep that in our cloud, remind us. So starting off with sine of 0, I go over here. My y value is 0. My r value is 1. So sine of 0, 0. Sine of pi over 2. My y value is 1. So it's 1. And I'll just go ahead and fill out the rest. Go ahead and copy all these down as well. Skip to pi. So sine of pi, 0 over 1, 0. Sine of 3 pi over 2, negative 1, 1, so negative 1. And then we have tangent theta, which is y over x. So tan of 0, sorry. So tangent, let's go ahead and look at this one. Our y value is 0. Our x value is 1, so it's 0. And then we go to tan of pi over 2. Our y value this time is 1, but our x value is 0. So this, because I cannot divide by 0, is undefined. Then let's finish up the rest. Tan of pi, 0 over negative 1, 0. Tan of 3 pi over 2 is negative 1 over 0. So that is also undefined. Undefined. Let's go with that. All right, so those are all of the ways to calculate trig functions at different angles. So we're going to be moving outside of quadrant 1 from now on and going throughout the entire realm. Okay, so make sure you understand all this. Rewatch, replay as needed, and have a great weekend, you guys.